Hello guys, are you all able to see my screen?
Yes, sir.
Yeah. So this is tutorial 8. Today we'll solve this tutorial. So I request all of you to download this tutorial from the Moodle. It is uploaded from on the Moodle and read the question. And I shall ask one of you to explain what is being asked in the first question. So all of you just download it from the Moodle and read the first question, and then we'll discuss at 5:10. Okay. You can also read it from here. My screen is shared. Mojahid Hussain, do you have any doubt?
No, sir.
Okay. Prakhar, probably there would be one more tutorial, like tutorial 9 will be there. I'm not sure about whether tutorial 10 will be there or not. Okay, so you, you'll be told in the next class whether tutorial 10 will be there or not. Okay, don't worry about that. You can consider it will be in the last week just before the major, last working week, whatever will be there. It would be that the term paper submission. Prakhar, is that clear? And to rest of the class also. So, hello guys. Uh, Someone read the question one. Would someone like to explain what is being asked in the question? Okay, no one is interested. So let me read it out for you. Like you have to develop a user-friendly program, like having multiple uh, to perform integration of this particular function, and you have to what you have to do in user friendliness, that you have to use multiple segments between 0 and 1. Like you can use two segments, you can use one segment, three segment, and so on. Like in that you have to divide the whole domain, and you have to apply one of these methods. Like you have to apply all of these methods, not one of these, but all of these methods, and compute what is the value of your integral, and find out the what is the error, and like analyze it, like with the number of segments, that whether it decrease or increase or whatever happens to it. So I hope the question uh, itself is clear. So now someone would like to tell like what we do in trapezoidal rule, like how do we apply for this function trapezoidal rule.
Sir, I have a question, sir.
Yeah, yeah, go ahead.
Sir, in this, we have to make a function for make a program for a general n, right? And then take a user input. What will be n?
Yeah, yeah, yes,
Sure.
exactly.
And
Like
and
you,
we
yeah,
and
go
to
ahead.
generate the data, how will we generate the data?
Eh, like you have developed user friendly program now for particular end, so you can use that function yourself to generate the data. Like you can use two segments, you can use four segments, just put in that and just copy paste it into the excel file. Like
Sure.
that,
Okay.
yeah. And then you have to compute the error there and find out what is being asked and so on. Okay, do it like that also. Is it clear?
Yes, sir. So we have to give the option of getting the integral at nth position and choosing any random, and we have to generate the data, right?
Yeah, yes, you have to do it. Yes, exactly.
What is n?
Yeah. So I was asking what is trapezoidal rule first. I'll come to N first. Trapezoidal rule. Tell me. Do you know what is trapezoidal rule? Last time we discussed, na? So someone please go ahead and just brief about it.
Like if we have a function named fx and we have 2 points and x1 and x2 and we have to find the integration between them. So as per trapezoidal rule, the formula for integration will be half of f of x1 plus f of x2 into x2 minus x1.
Yeah. So divide by two is also there. Yeah. So this is h by two times f of x1 plus f of x2, where h is x2 minus x1. Right. Um, So this is basic formula. Now here what is n? 1. Here n is 1. N here means the number of segments in which you will divide your domain. Like here the domain is 0 to 1. So you have to use either 0, one segment, that is from 0 to 1 you take only one segment, from 0 to zero point 0.5 and zero point 0.5 to 1 you can take two segments. You can take three segments, 0 to 0.33, 0.66, and 1, so on. So there are three segments in that case. So here they have shown like two segments. How you will calculate using when you have two segments in this. Is it clear what is n here now,
Yes, sir.
Yes, sir.
and how you have to calculate using? You have to compute this x1, x2, xn first, and then you can use this particular formula to apply to like just iterate upon all of the x1, x2, x3, and so on. whatever you have to calculate. Uh, so this is one thing, and true error finding is very straightforward. So you can find it like uh, whatever value you compute minus true error modulus divided by uh, this whatever true value is there. You get all of you got it, or should I repeat? Like true error, all of you understand now. This is eighth session, I think. So I hope all of you understand that.
So, sir, we need to take relative error. This true minus
No,
calculated upon true.
that is not true error. That is like true error. What is true error? Like percentage true error. You can say I am saying percentage true error. What is it? How much
Yes,
you
sir.
are deviating from the true error is calculated like this. Well, when we are talking about relative error is from just previous iteration which you are doing. Like there are several iteration you must be doing in this just before just one minus iteration and just one plus iteration. Mm, what is the difference between them and what is the relative difference between them, like epsilon I minus xi minus xi minus 1 divided by xi minus 1 or xiu, anything you can take in the relative error. But in true error it is strictly like true error true value minus whatever computed value divided by true value, that is the true error. So is it clear? Hello?
Yes, sir.
Yes, sir.
Okay, so similar thing you have to do in Simpson 1 by 3 rule. So what is Simpson 1 by 3 rule? Would someone like to explain what is the Simpson 1 by 3 rule? Go ahead, anyone? No one is interested to tell. Okay. So Simpson 1 by third rule is very simple. Like in that we are doing h by 2 times f of x1 plus f of x2, and that was all we are doing. So in this we are taking 3 points. We are dividing our domain already into 3 points, but segment is still, yeah. So we are dividing it into two segments basically. So x2 x2 between x2 and x1 and between x2 and x3, right? So h by 3 times f of x1 plus 4 times f of x2 plus f of x3. Now if I have to like take more number of segments. So I'll take in this particular rule, I'll take increment in the even number like 2 with like I have taken here two segments. So next time I will increment x4 and x5. So x1, x2, x3, x4 and x5. So there will be total 5 points will be there on this x domain. Because at one time you can take only, you have to take 3 points minimum. At the minimum you have to take 3 points and you cannot overlap two areas to calculate. So uh, so from from x1 x2 x3 you can calculate one time, and from x3 x4 and x5 you have to calculate second time. So from that you add both those and you get the total value of integral. Uh, is there any confusion, like what in what I said? I would clarify that. If it is clear, then it is absolutely fine. If there is some confusion, please go ahead.
Here n is equal to 2, right?
Yeah, currently n equals to 2. Yes. When you add x4 and x5, then n will be 5. N will be 4.
Okay, sir.
Okay. So Simpson 1 by third rule is clear, I am assuming. Now this true error can be calculated in a similar fashion like you calculated in that of trapezoidal rule. Hope that makes sense. And now Simpson 3 by 8 rule. So someone can someone just read it out for me, like what is Simpson 1 by 3 by 8 rule? Just I explained Simpson 1 by third rule and trapezoidal rule. Someone explain what is Simpson 3 by 8 rule. Go ahead.
So, like in Simpsons one third rule, we divided the area in two segments. Here we divide it in three segments, and 4
Yes.
points will be included.
Yes. Exactly. Uh, so perfect, Himanshi. So here the formula is slightly changed. We are including 4 points and we are including three segments, taking three segments at a time. So we are obviously expecting less error in this. So as we are taking more number of segments in lesser number of domain, so we must be expecting good results, right? So so here it is Simpson 3 by 8 rule. The formula is slightly changed from before. 3h by 8 times f of x1 plus 3 times f of x2 plus 3 times f of x3 plus f of x4. So now when you are going to increase the number of segments in this, so you will increase in the multiples of 3, right? So here currently the number of segments are 3. Now you will add x5, x6 and x7 and squeeze them into 0 to 1 domain, right? So there will be 6 segments total. Now, if you have to increase further, you will go to 9 because you cannot take in between. There is no in between. There's there will not any sense of taking 2 points and applying Simpson 3 by 8 rule. So Simpson 3 by 8 rule requires 4 points and 3 segments at the minimum to apply. So you have to move in that fashion and calculate your integral. So what is expected is like you should get minimum error in Simpson 3 by 8 rule and then Simpson 1 by 3 third rule followed by trapezoidal rule. So if you are not getting it, no worry, no worries. But there should not be like it is by very much difference. Like it should be a general trend, but it is possible that in this particular example this general trend may fail, but don't worry about it. But large difference should not be there. Like Simpson 3 by 8 rule cannot be very much wrong than Simpson 1 by third rule. Like both will give uh, almost equal results when Simpson 3 by 8 rule is not performing very well, right? So it is that kind of intuition should be there. Otherwise, in generally, Simpson 3 by 8 rule will perform way better than Simpson 1 by third rule, which in turn will perform better than trapezoidal rule that you will see in general. So you have to plot that graph in your reports and show that clearly in which the error is more, in which the error is less, and so on. Like how the error is varying with number of segments. You have to show all that in your report. I hope I'm clear with that. So I give all of you 5 minutes to read second question, and in those 5 minutes, you can also ask me the doubts related to question number one. So If there will be some doubts, I'll be happy to clear them. Otherwise, if you don't have any doubts, you can read question number second. Okay.
Sir,
Sir, in question number one, how many segments we have to take? Like we have to take one segment, then two segments, then three segments. So how till how many segments do we have to take?
Yeah. Till you are satisfied that that error is perfectly decreasing in this. So here it is not. It is left open ended to you. Like you have to make it out yourself that how many segments you have to take. Like you know the graph of convergence, how the convergence look like right now. You have the true value,
Yes.
true, true value of this. So till the error goes very less, you can take and up to that value and make it show that this is convergence. And like how you will know that which method is faster. So the method which attains the convergence faster is obviously fast, is clearly faster. And convergence with respect to number of segments. You have to draw the graph of error versus segments. So as you will increase the number of segments, you will see that the integral is moving close and close to this true value, and the error will tend to decrease, and it will almost vanish. So at whatever uh, number of segments it is happening, you have to do it for that number of segments. I hope I'm clear.
Yes, sir, got it.
Hello guys, do you have any doubt in question number one? If you have any, go ahead. So I'm assuming no doubts are there. If any doubt comes when you are solving that, so you can post on assignment out thread. So I'll be happy to clear there. Okay. So
Sir,
yeah, right.
sir, in question number one, we are supposed to develop a user-friendly computer program. But if the value of n that user enters is say 7, no 8, then for Simpson's 3/8 rule that is not possible because one,
So
2, 3, 4.
here user are you yourself. Simple.
Okay,
Are you going to enter 7? No, you don't have to enter 7. You have to enter in the multiple of 2 in Simpson 1 by 3 and in the multiples of 3 in Simpson 1 3 by 8 cube. Okay.
okay, got it.
So why user friendly? I've asked because you have to do it multiple times. So if you do not do it user friendly, then you have to again and again do it. Okay. That's it. Now this is about conversion in a plug flow reactor. So the diagram might look somewhat scary now, but we'll be really doing it in one of the course next semester. The exact equation you will be deriving how it comes from the basic mass balance and whatever things. So here we are not going to do that. Just to give you a perspective, like this thing you will be doing, and it is very easy. Nothing great in this. So here what is being asked that we are given some function, this particular function of volume, and this is a factor. This is here it is called prefactor. Prefactor. So it has a value of 2 meter cube, right? And the value of n which you have to take is 1.25. N is usually the order of the reaction, whatever is happening in this particular reactor. Uh, so and you are given you have to find the volume required for 90% conversion. 90%, this xn which is given here is this is the conversion. Whatever the conversion of reactant is happening in this reactor. So for the 90% conversion, that is you have to take x exit at the end of this reactor. Like you would be entering your reactant from this side, from the left side of the this, and your A is the reactant, and whatever conditions are there in this reactor are such that towards the end of this reactor, like from at at, at the L length of this reactor, you will get the product of the required uh, concentration, or like the reactant will suitably get converted into the product. Okay. So for the 90% conversion, that is x exit, you have to take it to be zero point 0.9. So it is nothing but integral 0 to zero point 0.9 dx upon 1 minus x to the power 1.25. So and this whole is multiplied by this prefactor, which is given out to be 2. So this is function is given in a very complicated way, and the things are very complicated in real life. So you can expect this kind of complexity. But when we translate it to mathematical way, the things looks very familiar to us. I would not say simple, but familiar to us. Like this is a function, like you can call it f or v, whatever you want to call it, and the function is 2 times integral of 0 to zero point 0.9 dx upon 1 minus x to the power 1.25. Okay. So so you have to find out the volume of this plug flow reactor. Now you have to find the at what length the 90% conversion will be achieved, because the cross section area is fixed. Cross section of area is fixed, so only length is the variable in plug flow reactor. So so you can directly find like what is the volume of the reactor required for the 90% conversion in this particular reactor. So so you, as I so, so as in the previous question, the function is given to us, and the domain is given to us, and we can apply all these three kinds of method again to to get our answer, right? So uh, here the here it is slightly different question. Like you have to find for what value of n, like for what value of segments, uh, you will get the appropriate tolerance. Like wh- like you, what will be the correct value? This tolerance is obviously relative, whatever relative tolerance you have to take. So here you are given with the tolerance. So how we are going to do this? Would someone would like to go ahead? Someone like to go ahead? Tell us.
Hello.
Yeah.
Sir, we can use an infinite loop until we reach this tolerance level, and when we reach this tolerance level, like we can know the value of n.
Yes, exactly. So we'll be increasing the value of n from, like in the case of trapezoidal rule, from 1 to 3, and put it in the while loop and calculate the relative error again and again. And as soon as the relative error goes below this tolerance level, uh, so we'll break out of the loop and say that this particular value of n, in which we'll be able to get the relative tolerance. Now one thing in this is like it is expected that you should get least like faster convergence for Simpson 3 by 8 rule, and then for Simpson 1 by third rule, and then trapezoidal rule. So this intuition you can keep into in your mind to get to check whether your results are correct or not. Okay. If there are some, like there the values are very close, like uh, then it is fine. But it cannot happen that the convergence is taking place for Simpson 1 by third rule in suppose 10 iterations, and it is taking 20 iterations for Simpson 3 by 8 rule. It is simply not possible. It is correct. It is straightforward wrong. So don't, for that kind of intuition, you can always keep the general trend into your mind that you'll get the least value for Simpson 3 by 8 rule, then for Simpson 1 by third rule, and then for trapezoidal rule. So, am I clear with that? If anyone have any doubt in this, go ahead, and we shall discuss it now.
Sir,
Sir,
what
the
is M
tolerance.
here?
What is
M.
M? Very
The
specifically.
prefactor, the value of
Yeah,
prefactor before the integral.
yeah. So it is written as 2 meter cube.
Okay, okay.
And so the tolerance here is relative, na?
Yeah. Okay. Tolerance whenever you are given, it is mostly relative. Is if it is not written, like you are not given the true value, then it is relative tolerance. So you have to uh, take the difference between the two successive iterations and find out the error with respect to that. Whatever you are doing till now, like in many assignments you have done. So I hope that that thing must have been clear to you.
This is not in percentage.
Yeah, not in percentage.
Sure, but we can calculate the true value analytically, and could we use that to like solve this question?
Like if tolerance is given, then you have to solve it by that only. No? Like why you will formulate your own question and then solve it. You can do it. That will be extra. You can do it for your satisfaction, but like what has been asked in the question will be evaluated on basis of that.
Also, sir, I had tried this question out yesterday itself when you had given it. So for that case, I realized that Simpson's 3/8 rule was taking seven more iterations than Simpson's 1/3 rule, and I like checked that two or three times. So is that okay?
So that is not expected. Like Simpson 3 by 8 will should converge more faster.
Yeah, but I've done it on. I've used the codes that we used for the first question. I've plugged in this equation in the codes for the first equation and checked it. So I know for a fact that it is correct.
So let us do one thing. Let everyone uh, do it first, and if many of you are getting the same results as Pratham is saying, so you just put on the assignment doubt thread. I think it is a mistake. Like if it is not a mistake, then most of you should get the same result because the code is not very much different in this. So you'll get same result. So if you get if many of you get the result as Pratham is saying now, uh, so you can put on the assignment doubt thread, and I'll check myself if this thing is happening, then this thing will be taken into consideration. Okay.
Okay.
And if someone is getting correct results, like the general, by correct I mean the general train, then you can also uh, put it on the uh, on your like WhatsApp group or anything. Like you can contact Pratham, you can contact if someone is getting correct result, right?
Okay, sir.
Yeah.
So what is XA exit?
This XA, hello.
The integration, the
Yeah,
upper limit.
yeah, this XA exit. So I was saying now that you are entering, you are making your reactant enter from the left side of the reactor, and it is coming out after conversion from the right side. So this is exit means what will be the conversion at the end. So at the end the
Okay, okay.
conversion is 90%. So point
90.
0.9 you have to take. 90%.
Okay.
You don't have to take it 90. You have to take it point 0.9 because that is conversion, not percentage conversion.
Okay, sir. Got it.
So if you guys have any doubt, go ahead. If we do not get any doubt till like say 1 or 2 minutes from now, so we'll end the session. We'll call it a day. Yeah. Go ahead,
Sir,
Pratham.
sir, in question number one, like we need to make a user-friendly computer program in the sense that we need to take the n value from the user and up
So
to
yeah,
we get the convergence, right?
yes, eh, yes, you have to make the graph of like what is the function of error versus number of segments. So it makes sense only you make till a convergence, like 1 or 2 iterations does not make any sense in that scenario. So
Sir, I had one doubt in this only.
yeah, yeah, yeah.
So for the user-friendly part, I had just given like we could input this number of segments we want or the subdomains, number of subdomains basically.
Yeah.
And so for that, then I'd created a program and then I'd put values like 10, 100, 500, 1000, 10,000. And so can I like use those values to just interpolate a graph then? Or should I like print each and every value for say 1, 2, 3, 4, 5, 6 up to 1000?
Uh, you you can interpolate like, but like you should take uh,
Huh,
sufficient amount of
use a sufficient
points.
amount of test cases, but I did not. I wanted to avoid the fact that I print out each and every error for each and every iteration. I could use a certain number of iterations and make a graph based on that.
Yeah, yes, you can make like one problem that you possibly can face in that scenario is that you have to compare for all the three, right? So like you are saying that you will be making for 10, 50, and then 100, then 1000 you'll make. So it is very likely that in the 1000 scenario all of those are going to converge. And
Hmm.
like, so in between you will be seeing a sharp difference between all of the three methods, like, and that you'll be seeing in the between also only, like, if you are going to interpolate when it is like in between, so you'll not be able to see the difference, like which is converging faster, which is converging slower. So that's why you can skip certain number of uh, uh, like segments, but like you can decide
Okay.
what is optimum number, so that you do not miss out that trend, like
Okay.
the Simpson 3 by 8 is most fastest convergent and
Can I
then the
like take gaps of 50 like 150, 100, 150 up to 1000?
yeah, sure, you can try and see like whatever fits the best should be. Yeah,
Because in my function, what I do is I take the number of segments and I then
yeah,
apply all the three rules and print out the values for all three rules together.
okay,
So if I put input 100, I get the value for that I will get from trapezoidal as well as Simpson's one third as well as Simpson's 3/8 rule together.
okay,
So I could like see a direct comparison just by inputting the number of segments.
okay. So yes, you can move in certain number of steps also, like you can decide on the basis of whatever your observation is, like,
Okay.
okay. So one thing you can do it like you do not want to print it out on your console, so you can directly print it out on your Excel sheet. That would be much faster.
Huh. Okay.
You can see like how to write on an Excel file directly. You know how to write on a text file directly. So there
Hmm.
is a similar method you can follow to write on Excel file directly.
Okay.
So with that, the work will be very fast.
Okay. Sure. Thank you.
Sir, in first question, it is not in percent, right? We have to print it without the percent, right? In first question.
For the error you are asking,
Yes, sir, ET.
yeah, ET. No need to do it in percent. You can directly do it in absolute like numbers only.
Okay, sir.
And sir, we need to compare all the three methods. So, like for trapezoidal, we can take any n. But in for Simpson 1 by 3, we need 3 points, and then for Simpson 3 by 8, we need 4 points. So, like, can we take LCM of 3 and 4 like, for
Yes,
12,
yes,
like that?
absolutely. You can take that way. Like you can move in steps of 12 for each and every, like for each and every, and you're not going to calculate for trapezoidal also. Like as Pratham told, like we have to move in gaps, right? So you have to decide the number of gaps, and if the gaps are the some multiple of LCM only, so that will be more good, like for the comparison purpose.
So, sir, the user is entering a single value of n. So, our program would give like only three answers for trapezoidal, for Simpson 1 by 3, and for Simpson 3 by 8.
Yes,
But for plotting that graph, we need to go till convergence.
yes.
So we can do that separately. Now for convergence, we can ourselves take a large value of n and we can plot that way.
But sir, if we go for convergence, then the graphs won't end at the same place, no? So can we do for some random number like 100 or something?
Like they want and it same thing. What do you mean by that? Like the
Like some
values
will
are,
converge first.
yeah, some will converge first, but like the convergence depend. You will never be reaching the true value. That you should understand that you will be reaching like 0.001, like one is 0.0001 far away, like in this fashion. So you'll be seeing the convergence almost simultaneously. You'll have to zoom in to see which have attained it faster. So don't worry. First try to do it, and if the doubt exists, then you can put it on assignment doubted. When you'll do it yourself, you'll find that almost all the curves are overlapping. Like very minor difference will be there in this particular scenario, because like the function is varying between 0 to 1 only. You can see the function is varying between 0 to 1. X is varying from between 0 to 1. So all these values are varying between 0 to 1. And the true value is also 0.60222. So there's very, you are going to attain the like what the convergence very much faster in with all of these three methods. You will have to figure out, like, that's why I was saying, like, it might take like uh, the Simpson 1 by 3 rule might attain a slightly better performance than Simpson 3 by 8, but it will be not very far away, right? But in a longer run, if you'll see for a larger function, like when you go at a higher values, like when from 0 to 1000 is there, and so on, such values are there. In such scenarios, you'll see that this is just going to boom up, and Simpson 3 by 8 will give you better results in case of larger values, and there the difference is more clearly visible. Here they are taking between 0 to 1, so you have to cautiously check what is your exact value. I hope I'm clear, Ayush.
Yes, sir.
So if you still face some problem, so you can put it on assignment without that, no issue. Takir, is your doubt also clear or something else?
Yes, sir. I was telling that suppose for trapezoidal we get the answer as 100. On 100 it gets converged. So we can take n value 200 and we can plot the graph for that iterations. So once we have the graph, then we can take the input from user that for what value of n we want the integration.
So that will be your back end work. Like whatever hit and trial you want to do, you can do it. You what you have to. You do not need to include in the report. Like even if you do it directly, I won't say that you why you have done it directly. You can do it directly, or like you can use hit and trial to get an intuition of like how much n you should take, like till what n you should go. You can do it that way also. No issues in it. Okay. Okay, then let's call it a day. If anyone have any doubt now, then go ahead. Otherwise, let's call it a day.
Thank you, sir.
Okay. Okay. Thank you
Thank
very
you.
much, all of
Thank
you.
you.